Welcome back. This is Dr. Lukes, and we're going to be looking at doing a bubble point example in this video, and we're going to be doing it using Excel as a solution tool. So, for this example, we want to estimate the bubble point temperature when the pressure is 3 atmospheres. And in this particular case, we have a mixture containing 20% benzene, 50% N-pentane, and 30% N-hexane. All of those are by mole. And this is the composition of the liquid phase. So we need to remind ourselves of how I would do a bubble point calculation. And from what we had in the lecture, we found that the pressure is the sum of the partial pressures, which is, by Raoult's law, the partial pressure is the liquid phase mole fraction times the vapor pressure for that substance. And so we would take each of those and sum those, and that should be equivalent to the total pressure. Now the problem is we don't know what the boiling point temperature is, and this is a highly nonlinear equation. So we'll be solving this iteratively for the boiling point temperature. In order to do that, what I'm going to need is vapor pressure data for each of the compounds, so benzene, pentane, and hexane. I have the liquid phase mole fractions, so I can put those in there. In the case of the data from the textbook, we're going to find that these expressions for the vapor pressure are going to be in terms of millimeters of mercury. And our pressure is given as 3 atmospheres. So we want to convert that to 3 times 760 millimeters of mercury. I've taken the mole fractions times the vapor pressure for each of my substances, but I have the temperature that is unknown, and we need to solve for that. So that's where Excel is going to be very handy. So I've already set that up, and if we look at this, so I know that the pressure is 3 atmospheres. I want it in millimeters of mercury. So I'll simply put in the formula 3 times 760, and I find that it's 2,280 millimeters of mercury. I want to know what the temperature is, the boiling point temperature. I really have no idea, so I'm just going to put in a guess. I'm going to guess 50 degrees. I really don't know. I've put in the liquid phase mole fractions, and I've put in the constants for the Antoine equation. Now, to compute the vapor pressure, the Antoine equation with the formulas we have is 10 to the power of, and I want to take the A minus B divided by the temperature, and I want to make sure I'm doing this by pointing to a cell containing that temperature, plus C. Okay, so now I have my expression here for the vapor pressure. I want to be able to copy that down to these other cells. If I just drag it directly, it's going to do all relational. So what I'm going to do is I'm going to come up here and I'm going to adapt this so that it holds the boiling point temperature cell as fixed, not relative. To do that in Excel, you put a $sign in front of the row and the column ID for that cell. So that's cell K2. I'm going to put a $sign in front of the K and a $sign in front of the 2. And you can do that by typing it in, or you can quickly do it by having your mouse on that cell and using F2. Or F4, excuse me. So I've used F4 to quickly change that to $signs, and then I'm just copying this down to the others. Now what the rule says is that the gas phase mole fraction times the total pressure, okay, right, that would be the partial pressure. But I'll be able to get back out of that gas phase mole fraction if I wish. That is going to be the same as the liquid phase mole fraction multiplied by the vapor pressure. and it would be that for each of those. The total pressure should be the sum of those. Okay. Now, with my guess of temperature, we see that we have 772 millimeters of mercury, and that's not what I'm wanting. I'm wanting it to be 2280. Now, I could come in here and try some random guesses, and I might try going smaller, and I see it gets further from the correct answer, so I go larger. Oh, wow, I went a lot larger. Okay, I really meant to do 60 degrees C, not 6,000 or 600. Okay, and I'm getting closer, but I don't want to have to play a guessing game. So, the key here is that I want to get Excel to do the work for me. I'm going to create a cell that is going to be my objective. And this is not the only way to do the problem, but this is an easy way to do it that is going to be adaptable for some future problems. So I'm going to create an objective that I want it to be equal to 0. So I want this to equal that, so the difference between them should be 0. I want it to be 0. Right now it's really not 0. Okay, so what I'm going to do is I'm going to highlight that cell, and I am going to come up to Data. And in Data, there's a thing called What If Analysis. So let me write that down, okay? So Data tab, I'm going to choose the What If Analysis, and within that I'm going to look for something called Goal Seek. Okay? So I've highlighted the cell, Data, What If Analysis, Goal Seek. Now what that's going to do is it's going to open up a little thing here. I'm going to set the cell that's highlighted to a value of 0. And I'm going to do this by changing this number right here. So I'm going to change K2 to get the pressure to really be 2280. Say OK. Does a little work. Gets it down to really close to 2280. I'm happy with that. And so the boiling point temperature is 88.17 degrees C. Okay. That's disturbing number of sig figs, so I'll just adjust that so that I know that that's not the exact answer. And if I want to know the gas mole fraction, it's simply going to be this divided by the total pressure. Again, if I want to be able to copy that, I'm going to highlight the K1, use F4 to put in insert dollar signs, and now I can copy those down and I have the gas phase mole fractions of all of my compounds. Okay, and again, F4 Okay, so just as a note there, so I was using F4 key to quick insert dollar signs. So that's going to be a way of solving a bubble point calculation that isn't very difficult as long as you have the tools handy. So this concludes our discussion of the bubble point and dew point calculations. Dew points are a little bit easier, so I have not done an Excel example on that, but they're a little easier and they do have some examples in the textbook.